Welcome to my 225th video on my work with OO gauge. In this video I'll be dealing with a Graham Farish OO gauge model of a Stanier Black Five locomotive that I picked up on eBay UK. I'll be checking the model out, disassembling it and servicing it as needed, and then I'll rebadge it as LMS rather than British Railways, and I'll finish with a little running video on my Bachmann layout in the basement. Here's the loco as it came to me sitting on my test tracks. The pieces in front of it fell out of the box when I unpacked it, and I've kept them in case they need to be reattached to the model, though I can't quite see how they might go. This model was sold on eBay for £50, but I'm in Canada, so I also had to pay $22.47 for shipping and £10.52 in import charges, going through the eBay Global Shipping Program. So the purchase ended up costing me $142.85 Canadian. The model did run in both directions on the test track, although it seemed to sometimes require a bit of a push to get it going. Here's a close-up of those bits that fell out of the packing. They look as if they might be related to steps, but I couldn't really see how they'd fit onto this model. The front steps of the model were in place on both sides. The cab steps, in a rather odd arrangement, were made up of a separate part pivoted between the back of the chassis and the tender drawbar. The cab steps on one side at the bottom here were actually broken off, but I couldn't see how the loose parts would fit to fix that. The mechanism employed by this model is very odd. It's designed for two-rail operation and picks up only with two plunger pickups on the tender. None of the wheels pick up at all. I guess you could compare this to the original Rovex model of the Princess Royal class, which became the foundation of Triang railway modelling. That initial Rovex Princess also picked up only with plunger pickups, though at least those were on the loco, feeding a motor in the loco that drove the loco wheels. This Farish mechanism is considerably odder. The pickups power a motor in the tender, which then rotates a drive shaft connected to the loco, driving the loco wheels through various gears. Here's the connection between loco and tender. Above the drawbar in this picture you can see the drive shaft, which passes power from the motor in the tender to drive the loco wheels. I do also have several modern Dapol N-gauge models that employ a similar system, with a motor in the tender driving the loco wheels via a drive shaft. But this is the only OO gauge model I have seen employing this system. I'm not entirely sure when this model was made. I'm guessing sometime in the 1950s. Here you can see the loco driving wheels. The centre wheels are driven, and you can see the driving gear here attached to the side of the wheel. Those centre wheels have no flanges, which should help in avoiding problems going round curves. Oddly enough, those flangeless centre wheels have traction tyres on them. Here's a view of the back of the tender. You can see the wires from the plunger pickups routed inside the tender through a hole. You can also see the rear coupling. The couplings on this model are of a type I've never seen before, just sheet metal loops with no hooks. Note that the centre tender wheels also have no flanges, so both loco and tender should be able to get round tight curves without any possibility of flanges jamming or causing derailment. Here's the front bogie of the loco with another of those weird couplings on it. I started disassembly by unscrewing the drawbar at the tender end. Here you can see the screw removed and the drawbar moved aside. Underneath you can see the tender end of the drawbar with the gears that drive it and a sort of universal joint to allow it to move. With the drawbar detached, I was able to pull the tender and loco apart. The solid square drive shaft from the tender fits inside a hollow square drive shaft on the loco, forming a very positive connection, but allowing loco and tender to be easily separated. Once the tender drive shaft is taken out of the loco drive shaft, it's free to fall down, pivoting on its universal joint. Next, I undid the screw at the loco end of the drawbar. This allowed me to remove the drawbar and also the pivoting piece with the cab steps. Here are those pieces after removal. As you can see, the bottom part of the cab steps is broken off on one side. Here's the bottom of the loco at this point. You can see the driving gear and the traction tyres on the centre wheels. You can also see the loco drive shaft, which also has a universal joint. Next, I undid the screw holding the front bogie on. And I removed the front bogie. You can see more of the gearing in the loco here. Here's the front bogie, which has plastic wheels and that odd little coupling. The only thing that I could see that looked like a possible body retention screw was this screw at the front of the chassis, so I undid that. With that screw removed, I was able to detach the chassis from the body. However, rather alarmingly, as I lifted the chassis from the body, the whole motion basically just fell apart. With the body not attached to the top of the chassis, there was nothing actually holding the motion together. The motion bracket and the cylinders were not fixed to the chassis at all. They were only held in place by the body. And the rods were only held onto the motion bracket by grooved flanges on the body. So those rods just fell off once the body no longer held them in place. At this point, I had to go back and look at my earlier pictures in order to confirm exactly how the motion parts were supposed to fit together. Some parts completely fell off as I took the chassis off the body, and other parts came loose and flopped about. After checking earlier pictures, I was able to see how the motion was supposed to go together. The part for the cylinders sits down against the front of the chassis. The motion bracket sits on top of the chassis. Actually, little pins on the top of the chassis are supposed to fit into the two holes on the top of the motion bracket, but I don't have those engaged in this picture. Then the eccentrics slip onto the pins on the ends of the motion bracket, and then the rods simulating the valve drive fit onto the motion bracket pins outside of the eccentrics, with the front of those valve drive rods fitting into holes at the top of the cylinder parts. You can also see here the universal joint connecting the loco drive shaft. In this picture you can see how the gearing of the loco works. A pinion on the end of the drive shaft drives a crown gear, which is then directly connected to a small gear on the outside of the chassis, which in turn drives a large gear attached to the centre wheel. I didn't bother to service any of this, since it all seemed to have been serviced quite recently, and was well lubricated and operating freely. Here's a closer view of the assembled motion. You can see how the eccentric fits onto the pin on the end of the motion bracket, and then the valve operating rod fits onto that same pin on the outside. And then when the body is in place, the grooved flange on the side of the body will fit over the end of that pin, stopping the rods from coming off. You can also see here how the motion bracket fits onto pins on top of the chassis, and the front of the valve operating rod fits into the top of the cylinder part. Here, I've actually got the motion bracket fitted properly onto the pins on the chassis. Note that the pins are of different sizes, so if you take the motion bracket off entirely, you won't be able to put it back on the wrong way round. The motion bracket and the cylinder part are only held in place on the chassis when the body is fitted on top of them. Here's the die-cast body without the chassis. You can see the grooved flanges on either side that hold the rods onto the pins of the motion bracket when things are assembled. Since both loco chassis and body are metal, this is quite a heavy model. At bottom right on the body you can see where it says Graham Farish Patent Applied For. Here's the detached body the right way up. The paint was a bit chipped, but otherwise it was in okay condition. Here's the front of the tender. The drive shaft is attached to a large gear with a fairly simple sheet metal universal joint. That gear is driven via other gears from the motor inside the tender. I wasn't clear how to disassemble the tender. The only screws that I could see were two small ones at the front of the tender chassis. You can see them here, to the right of and behind the front wheels. I tried loosening those screws. However, this seemed to be loosening the attachment of the mechanism on the front of the tender and not to be affecting the attachment of the body. Since I didn't want the mechanism parts to come off at this point, I tightened those screws back up again. I tried just gently pulling on the tender body and it came right off. The tender body was made of plastic and just seemed to fit over the chassis with no screws or clips or anything actually retaining it in place. With the tender body removed, you can see the motor inside the tender. I was a bit surprised because I believe I've seen pictures online of disassembled OO gauge Farish tenders, and the motor in those pictures was of an older, cruder type with large exposed windings. As you can see, this model had a relatively modern-looking can motor. Would that have been original, or was it a later replacement? I really don't know. The mechanism parts look relatively original, but the way the motor's held down by a piece of blue plastic with a hole in it seems a bit of a kludge. Here's the back of the motor with wires coming up from the plunger pickups soldered to pins at the back, and then wires to the brushes of the motor soldered in turn to those pins. And here's the front of the motor with the gearing. Note that the shaft from the motor has a pinion on it, but that pinion is not actually used. Instead, there's a threaded rod going right through that pinion on the motor shaft, and that threaded rod engages with an eccentrically bent shaft going to the external gear, which in turn engages with the gear to which the drive shaft is attached. The effect of this is that the shaft of the motor and the shaft going to the outside can rotate for about half a turn independently of each other before the rod on the motor hits the eccentric shaft. I assume this was done so that the drive shaft could be rotated at least a quarter turn without turning the motor at all, so allowing the shaft from the tender to be fitted into the hollow shaft on the loco without needing to turn the motor. I tried the motor using my bench power supply. I was able to run the motor and turn the drive shaft without problems. Again, it seemed that this mechanism had been recently serviced and was well lubricated, but not excessively so I basically left it alone. Here you can see the whole thing disassembled, but with the mechanism and motion parts put properly back into place. It wouldn't be possible to run it like this, since without the body in place the motion would fall apart. Having decided that I wasn't going to do any more servicing at this point, my thoughts turned to rebadging the model as an LMS engine, since I don't run BR at all, only pre-war and almost entirely LMS, the company my family worked for. My first idea was to use methyl hydrate, as I found this the best thing for removing tampo-printed markings. However, it didn't seem to work in this case. I concluded that these markings were actually decals rather than tampo printing. Was that an original Graham Farish thing, or had someone redone the markings? In any case, I've found that microset works very well for removing decals. You just dab on plenty of microset, then leave it for a while to soften the decal, then the decal can be gently picked off. Here's the plastic tender body with its BR crests removed. The issue of the loco numbering was a bit awkward. The loco was marked with BR number 44753. This would have been LMS number 4753, one of the very last Black Fives to be built for the LMS at Crewe in 1948, just before nationalisation. That loco was actually fitted with Caprotti valve gear. Of course, strictly speaking, that loco wouldn't fit with my pre-war prototype, but the numbers on the side of the cab were actually decals over the top of raised numbers cast into the metal, so putting on a totally new number would have been rather tricky. I settled, for now at least, with just removing the decals for the initial 4 digits, which were added to the front of the LMS numbers by BR. I pulled out some HMRS press-fix transfers for LMS crew markings, since those simple straw markings would best match the numbers on the loco. I pressed a transfer for LMS lettering onto the side of the plastic tender body, having checked the positioning on photos of real LMS Black Five engines. Then the backing of the transfer was simply wetted with water and peeled off. I did the same thing on both sides, marking the tender for LMS operation. The tender body was simply pressed back in place on top of the tender chassis. I fitted the loco chassis and body back together, taking care to hold the motion and cylinder parts in place properly until the body attachment was tightened down to fix them in place. Then I refitted the front bogie to the loco. And finally, I reattached the tender drawbar and the piece for the cab steps, fitting the drive shaft from the tender into the hollow drive shaft on the loco as this was done. By applying power to the plunger pickups on the tender, I was able to drive the loco wheels in both directions. Finally, I touched up the chipped paint a bit using Tamiya flat black acrylic. To try running the model, I took it down to my original OO gauge layout in the basement, which was made using Bachmann Easy Track. The model ran not too badly, although it was rather noisy and hesitated at times, mainly due to pickup issues, presumably. After all, pickup is only through the plunger pickups on the tender, so only one single pickup on each rail, meaning that any small discontinuity can cut power. I hooked the Farish engine up with a couple of coaches. I actually tried Hornby coaches at first, but the hooks on the Hornby couplings were sufficiently off-centre that they wouldn't function properly with the odd metal loop couplings on the Farish engine. I was able to get it to work drawing a couple of OO gauge coaches, also made by Graham Farish, although even here the coupling was a bit iffy, just relying on the hook from the front coach engaging with a loop on the tender. So anyway, let's finish with a little running video of that train. Okay, let me see if I can show this Graham Farish Black Five running on this layout. It's all a bit iffy, not least because, well, I mean the thing only has those two plunger pickups, so its pickup is not very secure, just one pickup on each track. And its coupling is bizarre as well, so it doesn't really couple very well to anything. Those are actually Graham Farish coaches behind it. You'd think it might couple to those, but not very well. So this may or may not work, because I know it's a rather iffy business, and I don't have a handheld controller on this, so I've got to... See, the problem is, he's going to get too fast, isn't he? But if I don't go fast, he's going to get stuck back there, you see, because he has trouble with those plunger pickups getting over things. And he also has trouble pulling the coaches. Whoa, sorry. The problem is I've got to crouch down to get at the controller. Not very well set up for a little bit more power there, a little bit less power. Oh, if I'm giving less power, he just stops. He's great trouble in that corner, doesn't he? Whoa, he lost the handle. It's not easy to do this. I mean, he's never going to be a good runner, but he's an interesting anomaly, isn't he? He's an older, he's a very different engine to most of what we do. I don't know. There you go, sort of. He's in the station there. So he sort of goes, but I mean he's never going to go very well, and I don't expect him to, but there you are.